Hey friends. So for those of you who are my kids at school, this is the beginning of our last unit on proportional reasoning. Okay. Um, I would say it's a fairly easy unit. It's a fairly quick unit. We're gonna spend about a week and a half on it. And then that's gonna wrap up the course. Okay. So super exciting. Today we're going to talk about comparing and interpreting rates. And really, you've been doing very similar stuff to this for a while, actually. Probably sometime in your junior high, you were approached with the topic of cross multiplication. Now, I'm not a huge fan of the word cross multiplication because I find kids use it in the wrong context and then they mess it up. But this will be an example where you do get to do cross multiplication. And essentially you get to do cross multiplication when you have a fraction equals a fraction. Okay. So anytime I have something like 3 over 5 equals x over 7 or something like that. Okay. What you can now do is say, okay, 3 times 7 is 21 and 5 times x is 5x. And then I can divide both sides by 5. And I'd be left with x equals 21 over 5. Okay. Now, why can I do that? Well, it's because algebraically, this is what's happening. If I just went 3 over 5 equals x over 7, I would want to multiply both sides by 7 to get rid of that 7 there, right? And so those 7s would cross out and I'd be left with 7 times 3 divided by 5, which is equal to x. And that's actually what we did when we cross multiplied, right? We multiplied the diagonal and then we divided by the third. Okay, so it does work algebraically, but that's kind of why it works algebraically. Okay, so cool. Let's take a look at this then. So when comparing rates, we often end up with a proportional situation. This means we have a statement where two fractions are equivalent. That means there's a fraction equals a fraction there, okay? When this occurs, we can solve for one of the unknowns from the equivalent statement. Always make sure your units are the same when you're doing a comparison. For example, you don't want one thing to have minutes that we're talking about and another thing to have hours that we're talking about. They would both have to say minutes, or they would both have to say hours. So that will add just another layer of complexity to some of the questions we ask you, okay? All right, so Carol can text at a rate of 65 words per minute. Jed can text 29 words in 5 minutes. Who is faster? Okay, well, the thing you want to see here is this per minute, okay? That just means that words are gonna go on the top, minutes are gonna go on the bottom. Okay, so all I have to do is take Jed's and go 290 on the top, 5 on the bottom, and figure out, that's called the unit rate. We're gonna figure out what Jed's words per minute would be. Okay, so I go 290 divided by 5. Of course, you paused me and tried this yourself, right? You know the drill, that's how you learn. That gives me 58 words per minute. So now we know that Jed can text at 58 words per minute. Carol can text at 65 words per minute. So Carol is faster than Jed. I'm just going to hide my face there in case you are someone who doesn't have the book, just so you can see the full question there. Okay. Awesome. Okay. If you're planning on a trip to Thailand, it's a good idea to bring some native currency with you. That's called Thai bahts. Using the currency table, calculate how much Thai baht you would be able to buy with 500 Canadian. Okay, now I have a little picture of an exchange here. I'm just going to hide my face so you can see the question there. Okay, but now what we're going to do is I'm just going to blow up that guy so we can see him a little bit easier. Now, what I want you to notice is there's two columns here. There's the we buy and there's the we sell. Okay, so we buy is what a bank would use when you have Thai bahts and you want to go back to Canadian money. What we sell would be when you have Canadian money and you want to buy Thai bahts from them. Okay, so you got to look at all these countries and you got to find Thailand's. Well, you can see Thailand's right at the bottom, and we're selling, or the bank is selling to us right now. Okay, and so this is the number that we're looking for. Now, what that number means is that one Thai baht is worth that amount Canadian. Okay, well, as soon as you have a statement like this, one Thai baht is worth 0.04210 Canadian, that is actually your first fraction. You can say one Thai baht on top and 0.04210 Canadian on the bottom. And then you set it equal to the information that you have. Well, you have 500 Canadian dollars. Okay, so I had Thai baht on top of my original fraction, Canadian dollars on the bottom. So I had to keep Canadian dollars on the bottom. If they were on the bottom, they need to stay on the bottom. Whoever was on the top needs to stay on the top. And I'm solving for my Thai baht. Okay, but take a look. Now I can just cross multiply. I can go 500 times 1, right? And then I end up dividing by the 0.04210. So 500 times 1 divided by 0.04210, and that's 11,876 and 48. Okay. Now, you have to always round currency to 2 decimal places. Okay, we won't tell you rounding instructions. It's just always assumed if we're talking currency, no matter what the currency, round to 2 decimal places. Okay. All right. If you're returning from a trip to Italy, you likely have some extra euros in your pocket. Calculate how much in Canadian funds you would have if you converted 3672 euros back into Canada. So you need to find the euro, which is right here. If you can see my mouse circling, okay. And this time though, you're asking the bank to buy it. So we have to use the we buy rate. So that is this 1.3325. Okay. And so we say 1 euro is worth 1.3325 Canadian. Okay. So that becomes the fraction that we set up. And so we have 1 euro is 1.3325 Canadian. I have 3672 euros. Again, euro was on top. So in my next fraction, euro had to stay on top. Canadian was on the bottom. So in my next fraction, Canadian had to stay on the bottom. Okay. And then we cross multiply. So this time when we cross multiply, we're looking at the 3672 times the 1.3325 and then divide by 1. Divide by 1 doesn't do anything, but that is the process that we're doing. Okay. And so that leaves us with 48.93 Canadian. 48.93 Canadian. I am going to just hide my head for 1 sec, just so that you see the full question if you don't have the book at home. Okay. All right, we'll clear that ink. We'll bring me back and we'll take a look at this. The following graph shows how a skateboarder travels over time. So over which time period is a skateboarder traveling the fastest? If you're traveling the fastest, you are covering, just think about this logically for a sec, you'd be covering the most distance in the least amount of time, okay? So visually, we would actually be looking for the steepest slope, okay? It doesn't matter which direction we're going right now, it would just be the steepest slope. Well, that's actually this one right here is the steepest slope. I covered, what's that, 5 kilometers in about 5 minutes, okay? So that's actually the fastest time that is happening, okay? Okay, over which time period is the skateboarder traveling the slowest? Well, right here between this 30 and 40 minute mark, I'm not moving at all. So I would be traveling the slowest if I'm not moving. So between the interval 30 to 40, they are not actually moving there, okay? And I know they're not moving because the distance isn't changing. Time continues whether you move or not, and that's what gives us the horizontal line, okay? What happens in the time period of 30 to 40 minutes? We kind of just answered that one. The skateboarder has stopped, taking a rest, talking to a friend, buying a Slurpee, I don't know, but his distance isn't changing, okay? what is occurring from 60 to 65 minutes? What we want you to notice there is, if this is distance, all the way up to 60, his distance is going farther and farther and farther away, which means he is moving away from wherever he started, okay? So maybe he left his home and is going to a skateboard park or whatever, okay? What's happening between 60 and 65, though, is that distance has changed direction, which means he is now coming back to his original destination, okay? So the skateboarder has turned around and is returning to the original destination, okay? Okay, let's take a look at this now. The following graph shows elevation versus time for a skier descending a mountain. During which interval of time was the skier's speed the slowest? Well, if I'm going to take a look at that, let's just compare each section. So what I want you to think about is from here to here, what has happened here? About 10 minutes have passed and I've gone, 100 meters, okay? Here we have 10, 20 minutes have passed and I have gone about 200. It's not exact, but we're just getting some quick ideas here. Now, this one seems to go much faster. And the reason I know it goes much faster is because only 5 minutes have passed and I'm going, from about 1, 2, so 150-ish meters, okay? And then here, take a look at this last guy. I've got 25 minutes have passed and I only went about 100 kilometers or 100 meters, okay? So when I see this guy right here, I'm thinking, oh, I've actually taken a really long time to go overall a less amount of distance. So my slope there is not as steep as the other ones, and that tells me that that's going to be going slower, okay? So my explanation here, my answer is in the interval of 35 to 50 minutes, this is the slope that is less steep than the others. So it takes more time to cover less distance, okay? Now, estimate the skier's speed for the interval. Well, if I'm looking for speed, I'm really just looking for the slope, okay? So I need this point here, which is going to be about 35, 925. And then I need this point here, which is 60, 800. Okay, so then I'm going to go 925 minus 800. Remember, slope is just y2 minus y1 over x2 minus x1. If I start with 925, I have to make sure I start with 30. I can't change the direction. So that'll be over 30 minus 60. Okay, so we end up with 925 minus 800 divided by 30 minus 60, and you end up with a rate of -5 meters per second. Now, don't get stressed out about the negative there. That negative is actually supposed to happen because the graph is going down. So that signifies a negative slope, which makes sense because I'm going down the mountain, okay? Okay, the gas consumption of a car on a 2-part trip is shown below. So I've got leg 1 in blue and leg 2 in red. The first question is, during which leg does the car have better fuel consumption? Explain how you know. Okay, well, I'm going to just pick on the 30 liters for a sec. Okay, for 30 liters, wow, that's a bad line, but leg 1 could get me 400 kilometers on 30 liters. Okay, but leg 2, there's the 30 liter mark. So that was only like 350-ish kilometers, okay? So I got less amount of kilometers on the same amount of liters, which means leg 1 has to be the better fuel consumption. Leg 1 has the better fuel consumption. Leg 1 got 400 kilometers on 30 liters, but leg 2 only got just over 300 on that same amount of liters, okay? All right, at which rate in liters per kilometer is the gas being consumed for each leg? Okay, so you just pick a point, find the liters and the kilometers that match, and then divide them. Okay, because it says liters per kilometer, that means liters has to go on top, kilometers has to go on the bottom. Okay, so for leg one, I chose 48 liters over 645 kilometers. That was this point given to me right here. And that's going to be 0.07, liters per kilometer. And then in leg two, I'm using this point right here. And it tells me 32.1 over 392, which is 0.08 liters per kilometer. Now, does this confirm your answer to the first question? Yes, because leg one is using a smaller amount of liters for every kilometer that it uses. So it does confirm that leg one has the better fuel consumption. Okay, awesome. So here is your homework for this lesson. Give yourself some time to go through it and make sure you're asking me lots of questions. That's what I'm here for. You guys got this. Take care.